Since I'm not able to be terribly accurate with the drawing on this, I'm not going to be able to do a graphical vector addition per se exactly the way that we do in class, but I will run through the exact steps that it takes to do it. The first thing that you have to do is you create a scale. Make sure you draw that somewhere on your page. So for example, of a scale of say 240 newtons, obviously I need to be able to convert that to my page, so I'm going to say something along the lines of 20 newtons is equal to 1 centimeter. The next thing that you would do is you would take that magnitude and convert it to your scale. So converted to my scale here, I can see that this magnitude will be drawn 12 centimeters long. And of course you'll need to do that for all of your other vectors as well. Number 3, when you finally have the page in front of you, you use your protractor to make a small mark setting your angle for the first vector. You then draw the exact length of that vector, 12 centimeters, which I won't have available to me here, so I'll just sketch it here. 12 centimeters at whatever angle that was placed by the original protractor. Once the first vector is drawn, you reset the XY axis, meaning that the next angle that you draw for your vector should start with a 0, still pointed in that direction. You're going to repeat all of that process, 3, 4, and 5, for any other additional vectors. So your line this could contain anywhere from 2 to really an infinite amount of vectors. I'm probably not going to be that mean for examples though. The final thing that you're going to do, once you're done, let's draw a couple of the vectors here. Say there's a vector up in the first, down in the third, over in the fourth. The final thing that you're going to do once you have 3 vectors drawn, or however many are necessary, is you draw the resultant vector. You draw from the 0 to the end point of the the final vector there. You measure the exact distance of that. If I use my scale here, it looks like that's roughly, I don't know, let's go 14 centimeters in this case. And then you convert it back to what the original form would have been. So I take this and I go the opposite direction. 14 centimeters being the case, meaning my final resultant would be 280 newtons. And then the last thing you're going to do is measure the final angle with your protractor. It looks like that's down over here in the third quadrant. So let's assume that I got an angle with my protractor of, I don't know, let's say 214 degrees. That's a quick review of the steps. If you need to see a little bit more precise result, come talk to me in class.